Okay, let's go through now the factor theorem, which is similar to the remainder theorem by plugging something in, kind of using that synthetic substitution kind of way of checking things. When a binomial evenly divides a polynomial, so when we do, x squared plus 3x minus 2 divided by x plus 1. X plus 1 is a binomial. If it's a factor, if it evenly divides, then that means our remainder is going to be 0. So the quotient of this division is called a depressed polynomial. So what that means is when I do the division, we get a polynomial that's 1 degree lower than the original polynomial. So if I were to do, as I said, x squared plus 3x plus 5, and I were to divide that by x plus 2, I don't know if it doesn't. I know it doesn't go into it. But let's say that it did go into it, then that means that my answer would be, some x plus something, because this would be 1 power lower than the next one, right? That's what this is kind of telling me. So the depressed polynomial has a degree that is 1 less than the original polynomial, which is what I just explained. A special case of the remainder theorem is called the factor theorem. So we are going to check to see if it factors, because, of course, if the remainder is 0, it factors. If the remainder is not 0, then it doesn't factor. Okay, so we're going to use the factor theorem. So we're given a polynomial, drag the remaining factors of the polynomial. So what we're going to do first is we're going to look at this here, and we're going to divide it by x plus 2. So if you remember, we're going to use synthetic division. So I'm going to do minus 2 goes into, because it's minus 2 because of that x plus 2. It's going to go into 1, 2, negative 8, negative 16. We're going to bring down the 1. We're going to multiply those together. We get 0 because we add those. 2 times 0, negative 2 times 0 is, of course, 0. That gives me negative 8. Negative 2 times negative 8 is 16. We add those up. So now you can see that we have no remainder. So if we have no remainder, that means x plus 2 is a factor. So x plus 2 is a factor. It's not a remaining factor, but it is one of the factors. Okay, so what I'm going to do is I'm going to circle it because I know that obviously it worked. Now, what does that mean? That means that we have to lower this degree by 1. So this 1 becomes an x cubed. This becomes an x squared, but because it's 0, I'm not going to write it out. This becomes an x, right? So we have things in there that we can work with. Actually, I take that back. So we have, I made a mistake. And so I want to point this out here, and this is good that I caught this because it wasn't working out the way that I thought it would. This is wrong. Now, let me explain why. And it's good to kind of go through that and see what happens, but how I like you to do things, right? You cross it out, because when you make a mistake, you want to know what you did. You don't want to erase it. If you erase it, you forget what you did. So 1, negative 2, 0, negative 8, negative 16. Notice here, there's a missing term, which I didn't catch. And so I had to put that 0 in for the missing term. So here we have x to the 4th, where the 1 is, x to the 3rd, x squared, x, and then the constant is over here. So, right, so we've got that constant, the value that's over there. Okay, bring it down, multiply. So negative 2 times 1 is negative 2, right? So we have a negative 2 there, okay, because that's a plus 2. So I can see that, and notice here, I also made a mistake here. No, I didn't. I made a mistake here. Man, I'm making mistakes all over the place today because I was like, why doesn't that disappear? That should be a 2. That should be a 0. Negative 2 times 0 is 0. Add those up, I get 0. Negative 2 times 0 is 0. That becomes a negative 8. Negative 8 times negative 2 is positive 16. That's going to be a 0. So notice it comes down to x to the 3rd. There is no x squared. There is no x. Minus 8. And of course, since this remainder is 0, there's no remainder. So that's what it becomes. Now we can factor this. And we learned how to factor this in an earlier lesson. That becomes x minus 2, because 8 is 2 cubed. So that becomes x minus 2 times x squared, the first one squared. At the end, it's the last one squared, so plus 4. That's where that comes from. Whoops, that plus 4 right over there. I think I clicked on something. And then we have in the middle, we multiply the 2 and the x together, and we change the sign. So it becomes plus 2x. So that's what it factors down to. So notice we have an x minus 2, x squared plus 2x plus 4. And there it is. These are my remaining factors for these, because this function, this initial function right here, would factor down to these 3 terms. And we already know that we figured out that one is already one of them, so we don't include it in the remaining factors. So we would just include the other 2, and that would be the answer. Okay, let me try to make sure I get this next one correct. So now we have 3x plus 1. So notice here, and see how I forgot to do that. I'm going to check it this time. Now I'm going to see, are there any missing terms there? No, it goes down by 1 degree every single time. So we have this here, but this isn't the setup for a normal way to divide it. So what I'm going to do is I'm going to divide both terms by 3. Okay, so really I have an x plus 3 there. Okay, or an x plus 1/3, I'm sorry. So we have an x plus 1/3. So that means that my term that I'm going to put on the outside of synthetic division is going to be negative 1/3, because that's this value right here. And then I have a 3 from here. I have a 4 from here. I have a negative 5 and a negative 2. Now, you may say, well, who wants to work with fractions? Actually, it's going to make it so that it doesn't work with fractions, and you'll see why, because that becomes a 3. 3 times negative 1/3 is negative 1. 4 minus 1 is 3. 3 times negative 1/3 is negative 1. Negative 5 plus negative 1 is negative 6. Negative 6 times negative 3 is positive 2, and that becomes a 0. So then we are left with 3x squared plus 3x minus 2, and that's what I get. Notice in this case I can't, I don't know why I said minus 2, minus 6. Okay, so then we have a minus 6, making all kinds of mistakes on this video. But you know, that's what you go back and you kind of check, you kind of relook and see, did I mess something up? But notice here I can take out a 3. So I'm going to take out a 3 because it's easier to factor when you try to reduce it down as much as you possibly can. So I have x squared plus x minus 2 because I divided it out. Whenever you factor, you're dividing out that number. And then let's see if we can factor this one. So we put our little table. We have negative 2. In this case, the negative is telling me that 1 is plus and 1 is minus. This positive is telling me that the larger one is positive. So I do minus plus, 1 and 2. Do those two add up to 1? Yes. Is the number in front of the x squared right now, is it a 1? Yes, it is. So these are just the factors. So it'd be 3 times x minus 1 times x plus 2. So it'd be x minus 1 and x plus 2 are my remaining factors, even though x plus or 3x plus 1 is also one of the terms as well. But these are the remaining ones. Okay, so that's how you work on that one. And that's it. You have some checks to do. Make sure you look at the checks and figure out which ones you need to do. Those are also written in Google Classroom, so I've got them in there telling you which ones to do specifically. Here's your homework in Reveal Math. This is also, if you're working out of the book, it will give you the information, but this is also on Google Classroom. And that's it for section 5.4.